So, as a psychology student, you really want to understand the basics of a psychological experiment. And I want to kind of put this into the context of overall research methods. So overall, there are three main types of psychological research method. In truth, yes, there's way more than that. But just to keep it simple right now, we're going to classify it in three major ways. The first one is causal or experimental research. So here we're looking about what causes something. That's the ultimate goal. When most people think about scientific experimentation, research on cause and effect is most often what comes to mind. And experiments on causal relationships investigate the effect of one or more variables on one or more outcome variables. And this type of research also determines if one variable causes another variable to occur or change. An example of this type of research would be changing the amount of a specific treatment and measuring the effect on the study participants. So a simple experiment is one researchers often use to determine if changes in one variable might lead to change in another variable. In other words, to establish this cause and effect. And in a simple experiment looking at the effectiveness, for example, of a new medication, for instance, study participants would be randomly assigned to one of two groups. And one of these groups would be the control group and receive no treatment, while the other group would be the experimental group, and they would receive the treatment being studied. So there's some basic elements that you need to consider within a simple experiment. A simple experiment really is composed of several key elements. You have the experimental hypothesis. So this is a statement that predicts that the treatment will cause an effect, and so will always be phrased as a cause and effect statement. So, for example, researchers might phrase a hypothesis this way: giving someone psychological treatment A will result in a reduction of symptoms of disorder B. Okay? So that would be an experimental hypothesis. Then there is the null hypothesis. And this is a hypothesis that the experimental treatment will have no effect on the participants or dependent variables. And it's important to note that failing to not find an effect of a treatment does not mean that there is no effect. The treatment might impact another variable that the researchers are not measuring in the current experiment. So there always needs to be that openness as you look at things. Then there needs to be the independent variable, and that's going to be the variable that is manipulated by the experimenter. And then, of course, you need that dependent variable, and that refers to the response the researchers are measuring. Okay? And as I already mentioned, you'll need the control group, and these are the individuals who are randomly assigned to a group but do not receive treatment. The measurements taken from the control group will be compared to those in the experimental group to determine if the treatment had an effect. And that, of course, brings us to the experimental group, that last critical part of an experiment. And this group of study participants is made up of the randomly selected subjects who will receive the treatment that's being tested. And so you need to go through this and determine the results of a simple experiment. And once the data from a simple experiment has been gathered, researchers will compare the results of the experimental group to those of the control group to determine if the treatment had an effect. Now, due to the always present possibility of errors, it's not possible to be 100% sure of the relationship between any two variables. There might be unknown variables at play that influence the outcome of the experiment. Just like clever hands. And so you need to be mindful of that. Despite this challenge, there are always ways to determine if there most likely is a meaningful relationship. And to do this, scientists use inferential statistics, and that's a branch of science that deals with drawing inferences about a population based on measures taken from a representative sample of that population. The key to determining if a treatment had an effect is to measure the statistical significance. Statistical significance shows that the relationship between the variables is probably not due to mere chance, and that a real relationship most likely exists between the two variables. So, for example, statistical significance is often represented with a p, and in this case, p is less than 0.05. And what that means is a p-value of less than 0.05 indicates that the results likely are due to chance, and that the probability of obtaining their results would be less than 5%. And there are a number of different means of measuring statistical significance. And the one used is really going to depend upon the type of research design that was used in the experiment. Okay, so that is causal and experimental research. But there's also descriptive research. And for those of you that do not like math and still want to get a PhD in psychology, this might be a way to go. This is often used, for example, in social work research. Descriptive research seeks to depict what already exists in a group or a population. An example of this type of research would be an opinion poll to determine people's beliefs about something. Descriptive studies really won't try to measure the effect of a variable. They seek only to describe the variable. And then there are relational or correlational research. And this is the study that investigates the connection between two or more variables. And this is considered relational research. The variables that are compared are generally already present in the group or population, so there isn't an experiment and manipulation that happens, but rather something like this. A study that looks at the proportion of males and females that would purchase either classical music or jazz music, and what relationship that has to gender and music preference. That might be an example. So overall, when we're interested in looking at scientific research, we need to keep in mind that people often confuse the terms theory and hypothesis. And they're not really sure what distinguishes the two. And if you're going to be doing any research in psychology, and obviously you are because you're going to be studying in this class, you're going to need to know the difference. So a theory really is a well-established principle that has been developed to explain some aspect of the natural world. So this would be that mythic level explanation. It's a story that explains how things work. And it's a theory really arises from repeated observations and testing, and incorporates facts, laws, predictions, and tested hypotheses that are widely accepted. So this is a story about how things work, but it's a story that has been refined over time and shown to be in a positive relationship between the observable facts and what the story says. That's what a theory is. What a hypothesis is something very specific. It's a testable prediction about what you expect to happen in your study. For example, An experiment designed to look at the relationship between study habits and test anxiety might have a hypothesis that states something like this. We predict that students with better study habits will suffer less test anxiety. Now, unless your study is exploratory in nature, your hypothesis should already explain what you expect to happen during the course of your experiment or your research. So while these terms are sometimes used interchangeably in everyday use, there's a huge difference when we're speaking in terms of psychological study and experimental design. So remember, a theory predicts events in general terms, while a hypothesis makes a specific prediction about a specified set of circumstances. A theory has been extensively tested and is generally accepted. It's a refined story, while a hypothesis is a speculative guess that is yet to be tested. And then, of course, you need to always be mindful of the issues of maturation in time, because people change over time. And that's one of the things that makes it difficult to study people. And so we have types of research that consider time in the process. We have developmental research, we have cross-sectional research, we have longitudinal research. And cross-sectional research really takes place at a single point in time, where all tests, measures, or variables are administered to participants on one occasion. And this type of research seeks to gather data on present conditions instead of looking at the effects of a variable over a period of time. So it's a snapshot in time. Longitudinal research, on the other hand, is a study that takes place over a period of time. Data is first collected at the beginning of the study and may then be gathered repeatedly throughout the length of the study. So, some longitudinal studies may occur over a short period of time, such as a few days, while others may take place over a period of time like months or years or even decades. And the effects of aging are often investigated through longitudinal research. Now, if you remember, in scientific research, what we're interested in primarily is the cause and relationship between variables. So what do we mean when we talk about a relationship between variables? In psychological research, we're referring to a connection between two or more factors that we can measure or systematically vary. And one of the most important distinctions to make when discussing relationships between variables is the meaning of causation. So a causal relationship is when one variable causes a change in another variable. And these types of relationships are investigated by experimental research in order to determine if changes in one variable actually result in the changes in another variable. And that's different from correlational relationships between variables. A correlation is the measurement of the relationship between two variables. And these variables already occur in the group or the population and are not controlled by the experimenter. So there's a positive correlation, and that is a direct relationship where as the amount of one variable increases, the amount of the second variable increases. Now, a negative correlation is as the amount of one variable goes up, the level of the other variable goes down. And in both types of correlation, there is no evidence or proof that changes in one variable cause changes in the other variable. A correlation simply indicates that there is a relationship between two variables. So the most important concept I want to leave with you here is that correlation does not equal causation. And oftentimes in research, that gets confused within the media. but as consumers of psychological research, I want to be clear that you know the difference.